Myself, Yame Japanese, working as a professor in the HRD College, Rajkot. Design of the machine element. My topic is called design of the machine element. First of all, what is the meaning of design? The design is the drafting process, which we are considering the actual thing. Which simply first we are doing the somewhat rough sketches and all that. That is the drafting process. But in that, from the drafting to the actual, that is the design. And for that, we have to select some materials and tracing process. The aim of the presentation was that to introduce to the structures of the machine, functions, tasks, and the load of the machine element, the main component method of the designing them. So for that, the main aim was that the different types of the structures on the machine, such as its functions, like the type, which types of the rows, which types of the ports, and all the functions are considering on the machine element. So for that, in this view, we are considering the fit and the tolerance, the basic of the square and joint that drive the systems. Okay, from in this figure, you are considering the different components, different parts of the car, which are disassembled. After the assembly of each and every component, you can see that the car is totally manufactured. For each and every simple or for each and every simple equipment, you can see that even this small bolt can also be designed. So for this, the total the car should be designed for that purpose. The mechanical chassis or the total equipment should be designed in the machine elements. The introduction of the machine element. First of all, the spring, fastener, bearing, shaft, gear, and in these are the all the basic elements of the mechanical machine design. So for that, it is the machine with universal joint, coil, bearing, and the fasteners. The general purpose of the machine design was that there are the static elements, the mechanical drive system, and the resistance time. This all the three are to working in the different parts. So in the static, we are considering the joint, frame, and the spring. But what is the meaning of the static? Static means what which is stable at one time, which is not require any type of the force or to move from one to the another. It requires force to move. If you will not apply any force to force, then it will not move. So for that, it will considering the elements like the joint, frame, the spring. In the mechanical driving system, we are considering the bearing, shaft, coupling, clutch, and the drive. The bearing is the equipment used to transmit the power, as well as we are considering the shaft, coupling, and the drive. So the four of them are considering the same to transmit the power from one shaft to the another shaft, or you can say from one equipment to another equipment to transmit the power. These all the things should be designed in the design of machine element service. After that, in the vessel system, or you can say that the pressure vessel, it is also designing in the machine element or the machine design. In that, we have to considering the pipe, vessels, tank, or the technical fluid for the purpose. So the general purpose of the machine design are these three main types, which are considering the joint, frame, and the spring as a static elements, bearing, shaft, coupling, clutch, and drive as a mechanical driving system, vessel type is pipe, vessels, tanks, and the technical fluid. Now the next, what is the material? What is the material design? Material, then after the design, after the manufacturing, money, optimization, opportunity, time, and the place. First of all, we have to select the material. Which type of the material or which type of the thing we should have to design. If we have to just take the simple example of a pen, if we have to design the pen, then which materials do we have to use? If we are selecting the material first, afterwards the selection of the material, then we have to design the equipment. First of all, just I said that the design of the pen. If I have selected the material, design of the pen is the plastic, then how the design of the pen should be made. After the design, the thing is going to for the manufacturing. After the manufacturing, the manufacturing purpose also manufacturing the item from the paper form to the actual form, and in last is the money, the optimize opportunity time and the place. The aim is the no failures, to no big deformation, no enough service time for that. So for that we can say that the no stress, no problem for it. The no failure, if the things that we are considering the material, As we have seen in the previous, we are considering the material. When the material relations fall, then we can say that the failure of the failure of the object. When there are no big deformation, enough service time, then all the things. So simply we can say now we are comparing to coming to this load. There are the basically three types of load: static, cyclic, and dynamic. The mechanical force related mechanical, thermal, and the chemical. Mechanical considering the force and the movement as well as the thermal which change in place of the time. There are the three types of graphs shown here. Static, that is the directly increment to the some point and afterwards it will remain to the constant with the force with respect to that. As well as for the cyclic. Cyclic means in the wave form. You can see that sometimes it will increase, it will decrease, then again it will decrease, and again it will increase. That is the cyclic form. We can see that. Now in the dynamic it is not the uniform. It is not in the static form as well as not in the cyclic form. It will be the varies from one part to the another part. Now the selections of the material. Which type of material we should have to select? That is the metals. In that the ferrous material, non-ferrous material, cast iron, steel, carbon or the alloy. These are the materials of the basic equipment we have to design. Now the plastic, ceramic and the composite. These all are the materials for which we have to selections for the design element. Now we have to conduct the see that the material density, conductivity, elasticity, plasticity, ductility, brittleness, toughness, and the grip. These all are the defects of the material selection procedure. If we are selecting the particular material of the plastic to make the heavy load, then it is we have to check that the plasticity of the material is what, elasticity of the material is what, ductility of the material is what, brittleness is what, grip of that material is what. So we have to check each and every point of the material selection for our equipment. The next is this load and this stresses. That is which type of the load, tensile load, shear load, and all are the distribution load in the uniform linear position. These are the uniform loads we are considering. The tensile load, that is the shear stress load, that is the non-uniform rotational. And for that we are considering the movement circle to considering the different types of flow. That is the loss of stability, that is the buckling and the elasticity of the and plasticity. If we are applying load from the upper side and the lower side, the bar is bending and it will considering the elasticity and the plasticity of that bar. Now the tensile test of that material is the load is equal to deformation. This is the straight strain diagram. If we are saying that the ductile of the carbon steel is rigid, it will remain it will improve in the constant increase and decrease in form. It will come at the yield point and it will be break at a certain point. In the rigidity cast iron, it will be suddenly increase and it will break at a certain point. It will not increase in the total formation. Now simplify the material model. It is the elastoplastic material, then it will be remain increase at the certain point, then it will remain constant. That is the plastic. And the elastoplastic means it will increase in the point, it will again remain constant, then again it will increase, and it will be get some enough break even point. And in the rigidity, it will increasingly constant and it will be breakdown. Now these are some tests was test, the L stress, ultimate tensile stress, breaking point, linear elasticity result. These are the straight strain curve with the material. If the equipment we are considered the uniform plastic deformation, uniform plastic deformation, nicking, fractures. This curve is showing the different stress strain. Here you can say that if we are considering any equipment that is the 0 to the 500 position, it will continuously increase. That is the linear straight region, and at the 500 point, it is the yield straight rod. After that, it will be curve region, that is ultimate tensile stress curve, and at the end of this is the breaking even point. Here you can say that this is the real curve generated by the straight strain, and this is the engineering curve generated by the straight strain of the mechanical equipment of the model. This is the straight hardening, that the new yield point, the loading and the unloading of the material. Similarly, the stress and strain curve is only in the purpose. Now is the elastic property. The elastic module is the E. We can considering the this stress is directly proportional to elastic module, and the strain, the shear module is G, In the megapascal it was conducted. And the same process as we have seen in the stress and the strain curve with the yield straight point and the ultimate straight point and the break-even point, that is the elastic point. The main material, the main static properties, that is the elastic limit, yield stress, ultimate stress, maximum stress, and the hardness stress. This is the influence of the stress strain conformation. This is shear force. The sigma is equals to shear, that is the force by area, and the maximum shear is the alpha shape factor into the sigma. Now this is the sudden area change in the fastening fatigue given the example of the screw, and it is the fatigue, that is the cyclic mode of the periodic state. It will be the propagation change and the failures are occur almost in the 90 to 95% over that. This is the whole curve, that it remain the load cyclic, that is fatigue limit. It will remain the constant. Here point the probability of the failure is 5% and the probability of the survival is the 95% in this curve. Type of the bearing load, that is the fatigue limit. In this we are showing that symmetrical, asymmetrical, pure, general, and the complex graphic, where R is equals to the load ratio. R is equal to cyclic hemispheric ratio, where the sigma max minimum upon the sigma max. Here is the sigma mean upon the sigma max. Now is the node sensitivity. The sum of the materials are not sensitivity to the nodes are simply implied by the theoretical stress factors. For this material reduced, the value of the Kt is used and Kf. In this material, it is the maximum stress is this. And it is the sigma real, the efficiency of K into the delta sigma max. As we have seen, that is the load time to the sigma and the sigma f into sigma f. Now the shear concentration factor Nk is the bulk minus 1 and alpha k minus 1. That is the stress concentrivity, and that now is the final is the safety of the factor. The safety of the factor is considered the load factor, all the bearing concentrations to be on the safe side. Used as the safety factor. The important particles of the element is important of the element manufacturing, materials testing, and the calculation. All the things are covered through the factors of the safety. When the factors of the safety is defined as the material stress, design of a load M is equal to greater than 1 equals to 1.5 to the approximate 8 to 10 elements. So thank you for that.